Okay, so we are doing 4-6. Oh, my auto image is acting funny today. See if we can't get a little bit better picture. Okay, that's better. Alright, we're going to do right triangle congruence today. Okay, this is 4-6. Before I talk about right triangles, so everything we've been doing, we're doing triangle congruence proof. So we've been proving triangle congruent, and then we had our third section, which allowed us to use CP/CTC to prove parts congruent. Let's review one thing that we studied. We studied the SAS theorem, okay, or postulate, which said that if I have two sides, two triangles. If they have two sides, 1, 2, and an included angle are congruent, then the triangles are congruent.
Oh, hello.
You want to sit with her?
Oh, yeah.
Okay, that's fine. You've got to be quiet because I'm recording.
Okay.
Okay. But it was really important that the angle was in between the two sides. If the angle is not in between the two sides, then the triangles are not necessarily congruent. I didn't go into detail on that when I first taught it, but I'm going to now. Okay? I'm going to show you an example. Okay? First thing I'm going to do is create a 30-degree angle. Okay? So I'm going to use my protractor. Let's do 40 degrees. For that angle, 40 degrees. I'm going to come over here and do a congruent angle. So I'm going to draw another 40-degree angle. That angle is also 40 degrees. Let me get another tool. Now I'm going to measure 4 centimeters. And 4 centimeters. And now let me go get one more tool. Alright, so far I have a congruent angle and a congruent side. Okay, notice I did not change the settings on the compass, right? So, I used a compass. I put the compass at this point, and I drew an arc, and I drew a matching arc over here. I'm going to draw one line from this intersection point for that triangle, and for this triangle, I'm going to draw the line at the other intersection point. These lines are congruent by construction because I used the same compass setting, right? That one is 3 centimeters. And this one is also 3 centimeters. So in this case, we have two sides and a non-included angle. Are the triangles congruent? No, they're not congruent. So as you can see, if the angle is not in between the two sides, then they're not congruent. However, it doesn't work when angle is not included unless it works when you have a right triangle. Okay? Let me show you the same exact example, this time with a right triangle. Instead of 40 degrees, we're going to use 90 degrees. It has to do with the perpendicular bisector, why it works. Other than that, you don't really need to know why it works. If you really want to know why it works, that's fine. Someday you can learn why it works. Like I said, it has to do with the perpendicular bisector theorem. Alright, so there's 90 degrees. Okay, let me draw another 90 degrees. Centimeters, 4 centimeters, now if I try to use my compass here, is there any possible way that I can get my compass to intersect this line twice? Okay. It's not going to happen, no matter where I put my compass. If I make my compass bigger, then it's only going to cross once. If I make my compass smaller, then it's not going to cross at all. Okay? So the only way I'm going to get this to intersect the line is one time. It will not intersect twice like it would up here. Okay? So again, if I put it over here, again, it's going to cross at the exact same point. There's no possible way that I could get two different triangles out of the same measurement. Okay, grab that one, and the measurement is, looks like 4.5. And that one is also going to be 4.5. So when it's a right triangle, it will work. Okay, so what do we call this? Well, there's an angle, a side, and then a side. But you're not going to get to call it ASS. Sorry. We're not going to let you curse in our classrooms. So the geometry gods, instead of calling it ASS, decided to call it HL. Okay? This stands for, since this is specific just to right triangles, hypotenuse leg. Okay, because you're always going to have, one of the sides is always going to be the hypotenuse. It's always going to be across from the right angle. Okay, and it will be either one of the legs. It doesn't matter which one. So it's called hypotenuse leg. So anytime you have this situation, you're going to get to use this theorem. So let's look at an example. The examples are going to look just like your other proofs. So that's why I spent more time explaining the theory behind it than actually giving you examples. Okay? Okay, so this is your only given statement. Notice you're not told anything is congruent, so you have to make those congruent statements in your proof and back them up with definitions. So, if this is perpendicular, okay, then what do we know about these angles? Let's call this B. Alright, we know they're 90 degrees, and what do we know about all 90 degree angles? So we would do our givens. I'm just going to say blah. Given. We know that all 90 degree angles are congruent. So angle ABE is equal to angle CBD. All right angles are congruent. If this is a bisector, then it is cutting these two in half. So CB is equal to BE. Definition of bisect. Actually, I'm going to change this. We don't need to say that those angles are right or that they are congruent. We just need to know that they're right. Angle ABE and angle CBD are right angles by definition of perpendicular. Alright, we need one more thing. Also in your given statement, CD is equal to AE. Okay, so we know that that is also equal to that, so that means the triangles are congruent by HL, because we have the hypotenuse is congruent to the hypotenuse and a leg is congruent to the leg. And we did have to say that it had right angles. You have to prove that it has right angles. If it doesn't already say it in the given statement, you have to have it somewhere in your proof that they are right angles, otherwise it's not a full proof. Okay? So there's your example. Like I said, I'm not going to do too many more because they all start getting really repetitive, so we will finish the rest of the examples in class as you do your work. All right, 11 minutes today, not too bad.